Alright, what we're going to do in this video is a demonstration of the acoustics of vowels. If you have not watched the acoustics of vowels lectures and introduction to vowels lectures yet, I would recommend that you actually watch those lectures before you come and view your lab demonstration of the acoustics of vowels. So what we're going to do here today is I'm actually going to record the sounds A, E, and U, and I'm going to draw the spectrogram, not me, the computer will draw the spectrogram of those vowels, and we're going to look at the formants. What I want you to pay attention on the spectrogram is how the formants are spaced, which is the F pattern. So if you have forgotten what the F pattern is or it doesn't come to your mind, just go back to your lecture notes where we have a slide that says the F pattern right here, which talks about the F pattern for the vowels E, A, and U. And then I'm going to show those exact patterns over here so you can take a look at that. Once we take a look at the F patterns, we also talked about the relative numbers of the formant frequencies, and they're not absolute numbers. So I have my teaching assistant Ashley Meredith here with me, and Ashley and I are both going to record the vowels, maybe the A, and then we are going to show you how the formant frequencies can vary because of our vocal tract configuration, because of our dialects, and so that'll be something interesting for you to observe. Okay, so let's get started. A, E, U. Okay, what you see here is just like the waveform up there that is captured. Now what we're going to do is we are going to draw a spectrogram. And in the bottom screen that you see here is the spectrogram of the vowel A, that's the first one, then the E, and then the U. Okay. Now what I'm going to do is draw a formant history. So remember again, let's revisit and tell what is a spectrogram. A spectrogram is the time on the x-axis, frequency on the y-axis, darker the striations that you see on the spectrogram, meaning they have more amplitude. Okay, so that is a spectrogram. And now if I draw the formant history, you see those beautiful colored lines that came up? And the red line represents formant frequency 1. The yellow line represents the yellow-orange, I'm colorblind, represents the formant frequency 2, and the green one represents F3. So we're only concentrating here about F1, F2, and F3. So if you recollect and go back to your lecture notes and say, what are the F1, F2, and F3 for A? It's around 700, 1090, 2000, greater than 2000. For E, it's around 300. The formant frequency 2 is greater than 2500, right? And your formant frequency 3 is around 3000 and higher. For U, your formant frequency is lower, first one, which is at 300. The second one is around 800. The F3 is greater than 2000. Okay. The interesting thing that I want you to observe is this F pattern. Look at the distance between F1 and F2 here versus the distance between F1 and F2 here versus the distance between F1 and F2. That's the F pattern. This F pattern is what helps us perceive these vowels more than just the absolute number of the formant frequencies. So if you look again, here is this y-axis here tells you the frequency. So my A is almost closer to 900. The first formant, and my second formant is almost closer to 1500, right? Again, remember, yes, we talked about it being 700 and 1100, but my numbers are a little different. Maybe influence of my dialect, influence of a female vocal tract that has a smaller vocal tract than males, right? So there are a lot of those changes too. And here your F1 is around 300, around 300. My F2 is almost closer to 2900 hertz. Right? And for U, if you look at it, it's about closer to the same thing, 300, and this is almost a little over 1000 hertz. But the idea that I want you to see is this, the acoustics of vowels. I want you to look at the different formant frequencies and the F pattern of these vowels. Okay. Now what we're going to do is I'm going to start a new recording, and I'm going to get Ashley and myself, we're going to record on the same screen the vowel A. And then we're going to see how there is differences to prove that the numbers are relative and not absolute numbers for formant frequencies. Okay? All right, Ashley, you want to come over? ah.
Ah.
Okay, those are two spectrograms that you see. One, a spectrogram by me where the ah that I produced, and the other spectrogram by Ashley. Let's now draw the form and history for that spectrogram. And you can clearly see how that the pattern, if you just look at the distance between F1 and F2 and F2 and F3, is almost the same, except a little bit of difference between F2 and F3. But F1 and F2, the distance between the two formants is almost the same, making us to perceive that as ah, but the numbers are different. So this is an indication that the one that helps us perceive the different vowels is the F pattern more than the absolute numbers of formant frequencies. Okay, so I think this is exactly what we talked about in the acoustics of vowels. We talked about the three different patterns, and hopefully this will give you a better idea of what a spectrogram is, what are formant frequencies for the vowels, what is an F pattern, and why do I keep emphasizing the F pattern more than the absolute numbers of formant frequencies, and how it helps us perceive the different vowels irrespective of dialectal variations, irrespective of vocal tract size and shape changes. All right.